on the record and introduce you. So Emily Marshman works in the field of physics education research. She did her doctoral work at the University of Pittsburgh, where she was a postdoctoral fellow at the Pittsburgh Quantum Institute. Since 2018, she's been a faculty member at the Community College of Allegheny County. Emily has publications on the problems students have with upper level quantum mechanics, how to improve student understanding of single photon experiments with the Mach-Zehnder interferometer, and many other aspects of quantum mechanics pedagogy. Her PhD thesis was on improving graduate students' knowledge of quantum mechanics, as well as their pedagogical knowledge. She's also studied questions of gender, self-efficacy, and motivation in physics. But today she's going to tell us about helping students develop a growth mindset, particularly in introductory physics classes. And as someone who's teaching an introductory physics course right now, I know we certainly have a dire need of that. So I'm greatly looking forward to this talk. So we're delighted to have you here, and welcome, and the floor is yours.
Thank you so much for the kind words and the warm welcome. And thank you for inviting me. I really appreciate the opportunity to share some of my research. I want to discuss with you some of the ways that you can help your students develop a growth mindset, some of the intervention that we did at the University of Pittsburgh, and hopefully you can think about adapting it for use in your own courses. I'd like to also acknowledge my co-researchers on this project. Some of them have moved on to Harvard University and some of them are still at the University of Pittsburgh. So just wanted to acknowledge that they were very helpful in doing this research with me at the University of Pittsburgh. Um, so our goal as physics educators is first of all to help students develop a robust understanding of physics. We want them to get an idea of the big picture principles in physics and how to apply all of those across different contexts. And another big goal that we have as educators is to help students develop problem solving skills, reasoning skills, laboratory skills, technical skills, troubleshooting. But we cannot forget that student motivation can affect the learning process, of course, and how much they engage with the material and how well they retain the material and can transfer their learning across different contexts. So I'd like you to take a moment. This might be a little bit odd, but I wanted you to take a moment to reflect back on your own experiences. Now we're thinking back as physicists right now, but reflect back on your own experiences in the physics courses, whether it was introductory or even advanced physics courses or graduate level courses. What did you enjoy about them? But were there aspects of the courses that made you anxious or nervous? Overall, how did you feel in the course? And is there anything that could have made the course better? Think about it for a minute. If you wanna chat, that's fine. I'm fine if you want to type something in the chat box. If you want to just share it out loud, that's fine too. Um, kind of think about back to when we were students and what was your overall feeling in the physics courses? It was a huge class. You kind of felt like you were in a sea of students. Um, I, I I have had experiences like that too. Suddenly made to answer questions, especially if not prepared. Yeah, you You kind of had a sense of, you know, what if I'm called out and I don't know the answer? My intelligence may be, not shown, uninspired, dry, unrelated to what I needed to make real things happen. Yes, very much so. Often not seeing the connection between the physics that you were learning in the classroom and everyday life, everyday applications. Um, Completely agree. Exams made me anxious. Yes. A moment of, in advanced courses, a moment of wonder, how did they ever come up with that solution? So kind of, awe of the genius of past scientists. Um, Once a professor set an expectation that they would bring materials to the class that enhance the text. I could feel positive anticipation. Good, good. Enjoyed the demos. Professors seemed excited about the subject. Yes, yes. So when you have those, more active learning activities, more hands-on type of activities, you could feel more excited about the course, and feel that the instructor was excited to help you learn more, and had faith that you could, right? So they made the environment a positive experience for you. Um, I completely agree with everything you were saying, and actually, we asked students. Lab courses were enjoyable than the classroom ones. Yes, I completely agree with that too. Applying, real world application and seeing where the lab breaks down, learning those troubleshooting techniques and the technical skills you needed for advanced courses. Um, we asked students about their experiences. Okay, we conducted one-on-one interviews with students to see what their concerns were. We asked them to do write written responses, and these are some of the things that they said, which it might resonate with some of us. Some people have a natural ability for physics, and as hard as I work, maybe it can become okay and do these problems well enough and have adequate grade on the exam, but I don't know if I can become truly fluent in it. Some people just have a natural talent for physics, but I can never do what they do. So you see the students discussing this idea of natural ability and natural talent in physics, okay? And that they don't have it. And so even if they work hard, they would never actually be able to achieve high level in physics. Another student said, I have pretty low self-confidence when I see how other people are so smart. Other people understand more than I do. I feel like I have to work a lot harder to understand something. So when you're sitting in a large sea of students, many of them appear to be extremely smart and have a lot of prior preparation coming in, can make you feel like you just don't belong. For physics, I feel like I can't connect things well enough. I don't have enough confidence that I'll be able to do it, and it makes me nervous. Again, this feeling of, do I belong here? I'm not feeling confident about my ability to succeed in this course. And another student said, I don't feel comfortable. It gives me a sinking feeling. It kind of scares me. So, possibly being called out, not knowing the answer to something and comparing myself to other people, it feels like I don't belong. So we can see issues related to students' sense of belonging, their mindset about what it takes to be a good physicist. Does it take natural ability or hard work? And their self-confidence are very common themes here. And this was actually at the very beginning of the physics course. So even at the beginning of the physics courses, they were feeling these pressures. On the written responses, students were concerned about how to balance, time management. They don't know many people here. So again, the sense of belonging, sitting in a huge sea of students, just not knowing many people. It's a lot different than high school. They've heard horror stories about weed out classes. So again, wondering whether or not they're going to be smart enough and not be weeded out in these introductory courses, and that they wouldn't understand their material or real world application. I'm sorry, I'm reading the chat too. I was fortunate enough to share an enthusiasm for learning physics and physics history, even though I also experienced questions of whether I was good enough. Yeah. So, you know, the point is, you may have these feelings, but you've got to have some kind of buffer, right? You've got to have some comfortableness in the classroom to be able to overcome these feelings of whether or not you're good enough. Do I belong here? Will I make it out okay? Not sure if I can make it through my classes. This student was also worried about balding, but that's another issue. This one always kind of made me really sad. They said, I am extremely worried that I have wrongly overcalculated my mental abilities by ending up in the engineering program. There's so many smart people around me, I feel like I do not belong. Okay, so they're coming in with these feelings already. Many of these students were freshmen coming into the engineering program in the physics course, and they just were overwhelmed with feeling like they just were wondering if they belonged in the course. And, these issues of being naturally smart also comes up a lot. I don't consider myself naturally smart, so I must work hard to be. So these are kind of the three aspects of motivation that I would like to talk about. I know the talk is about mindset and growth mindset, but I feel like that these three aspects are very connected to each other and feed into each other. So I don't want to skip over them. And of course, self-efficacy, sense of belonging, and intelligence mindset are aspects of student motivation. They're not the only ones. I'm just going to discuss these three aspects of motivation. Self-efficacy, you probably have heard of it before, but it's the belief in someone's belief in their ability to achieve goals or outcomes. And it's been shown to impact student learning. Students with low self-efficacy tend to give up and not put in the time for learning, and they feel threatened by challenging tasks. On the other hand, students with high self-efficacy attribute their failure to things which are in their control. So they challenge themselves and they recover from any setbacks that they face. Students with higher self-efficacy are more likely to persist and engage with the material. And it is actually a predictor of student performance over and above prior knowledge and skills. And if students have a good level of self-efficacy, it's often linked to effective learning strategies and the students and the goals that students set for themselves, whether it's a goal to just get an A or is it a goal to actually learn the material, and overall their academic achievement. So we want to think about ways that we can help students develop a healthy sense of self-efficacy, which was something that we saw in those quotes from the students. And another aspect of motivation that I'd like to discuss a little bit with you today is the sense of belonging in the classroom. It plays a huge role in student retention and learning. When students realize that their struggles are normal and it's not a sign that they're not cut out for college, and that they are reassured that they do indeed belong in the course and at college, they do work harder and they work better. There was some studies involving African American students in college who were asked to read survey results from other students, showing that most students, regardless of their gender or race, worried about whether they belonged at college. And then, the surveys showed that as they went through, they started to feel better and they started to feel at home, and the difficulties they were facing kind of faded with time. So the African American students who read those surveys and kind of internalized that message, even after 4 years of college, they were earning higher and higher grades compared to the control group, and they even reported better health outcomes. So a very brief little intervention at a critical time in these students' lives made a big difference over a period of 4 years. And lastly, intelligence mindset was coined by researcher Carol Dweck. And intelligence mindset is an aspect of motivation that can also affect learning. If you have a fixed intelligence mindset, You believe that intelligence is static and it can't be changed. It's kind of an innate quality. You have an innate ability. On the other hand, if you have a growth intelligence mindset, you feel like you can stretch your learning, stretch your brain, that intelligence can be grown. Students with a growth mindset thrive on challenge, and they believe intelligence can be stretched and cultivated through effort. But if you have a fixed mindset, you might give up easily on tasks and not engage in challenging tasks because you fear failure. And if you have more of a growth mindset, you're aware that failure and struggle is okay and it's a stepping stone to learning. So there's a continuum. It's not really like you're in one category or the other, but we want our students to develop more of a growth mindset, especially in learning physics. This mindset can actually be be set up very early in life. There were studies that show that four-year-olds, they were shown some jigsaw puzzles and they, wanted to solve the students with a fixed intelligence mindset just kept wanting to solve the same puzzle over and over again. They didn't want to challenge themselves or try harder ones because that would show that they maybe weren't very good at solving jigsaw puzzles. And they just wanted to affirm their existing ability that they could solve that particular puzzle. And then on the other hand, the four-year-olds with the more growth mindset, they wanted to try harder jigsaw puzzles. So they really wanted to try to become smarter and stretch and grow their intelligence. And another interesting study that was done regarding intelligence mindset is that there was adolescents were given 10 challenging problems, and after they solved the problems, they were broken into two groups and they were given different types of praise. In one group, the students were told, "Wow, you solved 10 out of 10 of these problems. You must be really smart." They were praised for their ability. And in the other group, the students were told, "You got 10 out of 10 problems right. You must have really worked hard on those problems." So they were praised more for their effort. When the two groups were offered to solve more challenging problems, the group of students that were in the ability praise group um, did not enjoy that task very much. They didn't want to solve harder problems. Um, be- and when they struggled to solve the harder problems, they attributed that to, well, I'm just not smart enough to do it. So I don't really want to solve any more of these problems and I don't enjoy it. And the students that were in the effort praised group, when they were given the tougher problems, they did struggle with it, but they didn't attribute their failure to their smartness per se. They attribute it to that they just needed to practice it more, that they needed to put more effort in. And the effort praised kids, they enjoyed the problems and they had more fun. And actually, they kept getting better and better at solving the harder problems as time went on too. So mindset has a huge impact on your motivation to learn and learning outcomes as well. I wanted to unpack mindset a little bit further since this was the focus of my talk. When I was doing some research at the University of Pittsburgh along with Zainab Calendar, we asked students in physics courses several different types of mindset questions. And we noticed that there were some differences in how students answered these mindset questions, whether the question was about themselves personally or if it was about others. So we kind of put the mindset questions into four different categories, whether the mindset question focused on effort or ability, which is the growth or the fixed intelligence mindset. But we also looked at the axes of questions about myself versus questions about others. So in the quadrant that focuses on my own fixed ability, a question example would be like, if I really have to struggle to solve a physics problem, that means I'm not a physics person. And I'm sure we've all heard that before. I hear it all the time when I'm not a math person, I'm not a physics person. Or on the other hand, you might answer a question about others' growth. So anyone can become good at solving problems through hard work. Okay? And so the questions actually fit into 4 different types of categories. And we noticed that the largest gender differences actually occurred on the questions about my fixed ability. We saw that females were more likely to agree with this statement than males. And it was the, the answers to students' questions on these kinds of particular fixed ability questions were predictors of the gender gap in the course grade, at least one part of it. And so it was interesting to see that females maybe recognize the value of working hard and putting in effort, but they still carry beliefs about themselves that they still need a natural talent to really achieve high levels of achievement in physics. And so the takeaway from that was that, you know, they might be thinking that maybe others can do it, but I can't do it. Maybe others, if they put in the effort, they can learn physics, but there's still something about me that I'm not a physics person that I'm not going to be able to. And so these are important issues because we know messages students receive about what it means to be a physicist. And over the past 100 years, not much has changed in terms of the diversity in the physics world. And so some students just may feel like they don't belong, they aren't smart enough, and they don't have the capabilities to succeed. So I like to think about this as kind of as an offense and a defense. So when we ask students to go on the offense, so engage in effective problem solving, transfer their learning, develop a robust understanding of the physics principles, that involves a lot of risk on their part because they're inevitably going to make mistakes. They're going to identify gaps in their understanding, and they're going to realize that they may not know everything. And so helping students enhance their defenses, kind of having a buffer, involving having a good sense of belonging, having more of a growth mindset, and having a positive self-efficacy. Students are more likely engage in these challenging problems and, stretch their intelligence in physics. So these are the kinds of questions that we ask students to answer. Um, in terms of sense of belonging, do I belong here and do people like me belong here in the classroom? In terms of intelligence mindset, we ask questions like, I need to have a natural ability to succeed in a physics course. And students were asked to whether they agreed or disagree with the statement on a Likert style survey. Or, no matter who you are, you can change your intelligence quite a lot. The self-efficacy questions, so they were things like this. I am often able to help my classmates with physics in the laboratory or recitation, or I get a sinking feeling when I think of trying to tackle difficult physics problems. And so these are kind of the defenses that we want to help students develop so that then they can go on the offense and really engage with learning physics better. For some students, a potential trigger for diminished self-efficacy and sense of belonging and more of a fixed mindset is a stereotype threat. Stereotype threat is the fear of confirming a negative stereotype about oneself. And in physics, unfortunately, women and underrepresented racial minorities may feel these negative stereotypes more saliently. If you do feel like you're afraid of confirming this negative stereotype threat, you may attribute your struggle or a poor performance to an innate fixed cause, right? It's me. People like me aren't smart enough to do physics, and this becomes demotivating because then they think, what's the use of even trying if I can't succeed? And so this is especially an issue in times of uncertainty and ambiguity. For example, the beginning of a freshman physics course when you're coming into college, or maybe the first time you take an upper division physics course, or maybe even when you go to grad school, or when you transfer to, a bigger college or university. In times of uncertainty and ambiguity, you may begin to feel like, do I belong here? Your identity becomes threatened, and some may experience stereotype threat. They begin to feel that their intelligence is a fixed thing. They experience decreased self-efficacy, and all of these things are, taking up cognitive space in their brain, and it's hard to focus on learning the physics, so they have diminished performance. And then that feeds back into, well, see, I don't belong here. It becomes a negative feedback loop. So we want to intervene at these key times where, um, yes, I agree. We want to intervene during these key times of transition and help students get more into a positive feedback loop as opposed to this negative feedback loop. And so um, that's what we decided to try to do at Pitt. um, so first of all, we wanted to kind of get a baseline first of all to see, where are our students in terms of their self-efficacy and their mindset and their sense of belonging. And so we gave survey in the introductory calculus-based physics courses, which are approximately 1/3 female. These are the courses for engineering and science. And we predicted that there would be gender differences in these aspects of motivation. And so I will show you what we found. We did indeed find that there were gender differences. Here were the self-efficacy questions that we asked on this motivational survey. They answered on a scale of 1 to 4 whether they disagree or agree with these statements. And we took an average across these questions. And what we found was that females who are in the dotted line versus males in the solid purple, there were significant differences between their level of self-efficacy. 4 means a very positive self-efficacy. 1 means a very negative. And we actually gave this at 3 points in time: the beginning of the fall semester, which would be at the beginning of Physics 1, and then at the beginning of the spring semester, at the beginning of Physics 2, and then at the very end of our Physics 2 course. And what we found was that there were females had reported a significantly lower level of self-efficacy, and that gap started to widen by the end of Physics 2. So it was what we predicted, but we don't feel good about that, especially because it seems to be getting worse. I mean, everybody's kind of going down a little bit, but um, prior studies have shown that that's usually what happens as students go through the physics courses. But the fact that we saw these larger gender differences here was disappointing to us. And we also did the same thing for the mindset survey questions and the sense of belonging survey questions. We didn't give those 3 times, we only gave that once. So I only showed one point in time for that. Um, a 4 means you have more of a growth mindset, and a 1 means you have more of a fixed mindset. So females showing more fixed mindset views in physics as opposed to males. Not a huge difference, but it was statistically different. And there were some of those questions in which we saw even larger differences about the my ability. And then the sense of belonging, that was scored out of 5, so it looks a little wonky on the graph, but the females were reporting, again, significantly lower sense of belonging in these courses as well. And so we know that these aspects of motivation have real effects on student learning, and so we wanted to do something about it. So we looked into the literature, and there have been different types of interventions that have done to address some of these issues involving belonging and growth mindset. Um, the social belonging intervention is a brief, the ones that are discussed in the literature, usually very brief, maybe 1 hour long reading and writing activity that can be done inside or outside of class. The social belonging one, it usually looks like something where students read surveys from students that have already graduated from this course, talking about how they had a lot of worries at the beginning, but those worries and struggles decreased over time, and they eventually feel at home in the course and at college in general. And then the students that are in the intervention are asked to write a letter to a future student, um, to help them, to give them tips on how to adjust in going to college. So that letter kind of helps them integrate and kind of personalize the message so it sticks with them a little bit longer. But it's just a 1 hour long reading and writing activity. And then the growth mindset intervention, again, it's short, 1 hour long. It usually involves showing students some neuroscience research on how the brain actually does change as students learn, um, along with testimonials from students that have gone through the course to help them, to show that, yeah, I struggled with these concepts a lot, but it just practiced it. And, you know, if I used effective study strategies, I could grow my brain and get smarter. And these were implemented during times where there was a sense of uncertainty, a transitional time. And they're meant to show that students' struggles are very normal and universal. Many students are experiencing them, so they're not alone, even though sometimes you feel alone. And that the challenges that they face are temporary and gradually, resolve themselves over time. This isn't this isn't a cheerleading session. We're not trying to say that they're never going to face a challenge or struggle or, get a C or a D or an F on an exam, but these are normal things that most people experience when they go to college, and they're to be expected. And, it'll it it's a learning opportunity for them. Um, So what we wanted to do at Pitt is kind of combine these two, social belonging and growth mindset, into one kind of intervention, because it seemed like that these two kind of go hand in hand a bit, and that those were concerns that many students had been mentioning in their written responses in the interviews. So what we did was we implemented these kinds of interventions at the University of Pittsburgh in our physics for engineering and science majors courses, which are the calculus-based courses. Um, 1/3 of them were female students and 90% of the class is freshmen. Okay. And so the intervention was led by myself, a couple of other grad students in the physics program. And what we did was we went into the recitation section in the second week of class, and we went to them and we said, we are representatives from the physics department. We are interested in improving teaching and learning of physics at the University of Pittsburgh, and we want to know what you're concerned about. We want to get your feedback on, some of the issues that you're facing and ways in which we can address that and help you succeed in the physics courses here. So that was during the recitation, where it's a problem-solving session. They meet once a week. It's led by a TA. So we went in the last maybe 20 to 30 minutes of the recitation, and we introduced ourselves, and we mentioned, it can be easy to feel overwhelmed and wonder, do I belong here? Do I belong not only in this class, but do I belong in the engineering program? Do I belong at Pitt? The control group classes did business as usual. So they worked on problems in small groups while the TA went around and helped them solve the problems. Our message was, these kinds of experiences are normal. Everyone kind of goes through them, and they do get better as you adjust to college. And we had the students do a brief reflective writing activity, maybe for 5 or 10 minutes they wrote. And the writing exercise asked them to write about some of the concerns they have about colleges, the challenges and the transition, worries about the coursework, or thoughts about taking a college physics course, and how they think the concerns will change over time. We asked them to be anonymous, although we did collect them, but they did not put their name on it. Um, so the students, I already showed you some of the things that they wrote about at the beginning of the talk. But here's a couple more of the student responses. Um, he was a This student was afraid they would end up stuck with a constant state of extreme anxiety, concerns about how to pay for college, learning too much excess useless knowledge that does not aid me in what I'm majoring in. So again, this idea of, is this applied to my major? How am I going to apply what I learned in this physics class to my career? So many issues students face. I feel like the vast majority of kids are both more interested in and more competent in math than science. I know various people that are simply better at math and that they got deferred out of the engineering program. So again, this comparison, wondering if I'm smart enough to make it, feeling like whether do I belong or not. I'm worried I'm not smart enough. This came up many, many, many times in student responses. And this student also brought up their prior preparation from high school, that they did have to work really hard in high school, and they're wondering, is it going to be worse in college? So they wrote for maybe 5 or 10 minutes on that writing activity, and then gave them some quotes from graduating seniors designed to highlight the challenges and the loneliness. These quotes were actually developed. They were kind of a combination of quotes from myself and other experienced graduate students. So they were more curated quotes, but since I've left, I believe that they have gotten real quotes from real students to listen to. And so this is an example of one of the quotes. Um, it's a narrative. It has a beginning, a middle, and an end. So at the beginning, the student says, I was one of a handful of women. In my physics study group, I felt a little bit embarrassed to ask questions. However, I learned that other students usually had the same question that I did, and we all benefited from working with each other. Sometimes I had difficulty with an idea that my classmates understood. Other times they struggled with concepts that I understood. It wasn't always an aha moment. It was usually much more gradual, with some concepts becoming clear after lots of practice. I realized that everyone struggles, and the important thing is to not give up and help each other out. So bringing into light the initial sense of feeling like she didn't belong, but learning to kind of work within a study group. And as time goes by, she realized that other students were struggling with the same things that she did, and over time that it got better. Um, and after we showed the students the quotes, we asked them to break into small groups, which they had already done because they were already in a recitation section in which they were working on physics problems. So they discussed their reflective writing activity and and the quotes with the teammates. And I got to say that the room got really loud at that point. I was surprised. I didn't, when I did this intervention, I was a little nervous about how the students would take it. Um, but the room got very loud. You could see that they were really engaged with each other, and they were discussing a lot of different things. And these small group discussions helped the students realize that they're not the only ones that are facing these issues. Lots of people have the same kind of challenges. They're not alone. It reduces anxiety and uncertainty about whether or not they belong in the classroom. And it kind of made everybody a little bit vulnerable and kind of connected the students a little bit more. And then lastly, we actually stepped it out even further and had a whole recitation-wide discussion. So I asked the different groups if they wouldn't mind volunteering what they talked about, and many of them did. And, as they shared some of their concerns, you could see other students in class nodding their head and, you know, um, kind of just realizing that we're all kind of facing the same issues. We're all in the same boat here, and we just kind of have to work through and make it through. And that was it. That ended the intervention. So it was about 20 to 30 minutes long at the end of the recitation. And after it was over, I remember a lot of the students came up to me. Again, I was surprised. I didn't know how this was going to be, but I remember a lot of students coming up to me after it was over and thanking me for coming and saying, we really appreciate that you're wanting to improve the classes, and we're appreciative that you want to take our concerns into account. And it was really good to hear from the rest of the class too. So it went surprisingly well. I wasn't sure how it was going to work, but I was surprised. And the TA, so the TA that was teaching these recitations, I remember the TAs coming to me throughout the semester, because this was it. I left, we never came back again. The TA came to me later on, maybe midway through the semester, and said, remember that thing that you did at the beginning? I feel like that did make some kind of difference. They couldn't really put their finger on it. It was anecdotal, but they said that the students, were more willing to work with each other, were more willing to ask questions. They seemed like they had more of a camaraderie within the class. Um, so it's not a data point, but it was encouraging to see that the TA could tell a difference between the experimental and the control group. And so what we found was that so we wanted to see, did this make any difference in terms of their performance? Um, so the analysis that we did, along with I worked along with Yasmin and the other social psychologists from the psychology department at Pitt. We analyzed this. They controlled for the demographics of the participants, so race, gender, instructor, SAT, math and verbal, and high school GPA. So what we found was that we found that in the control group, the gender gap in the average course grade between the male and the female persisted. Okay. But in the social belonging and mindset intervention group, we were happy to see that the average course grade, that there was no difference there between the male and the female students. So that was encouraging for us. And we also broke it down a little bit further. On the survey that we gave at the beginning of the semester, we also asked questions about students' math self-efficacy. And so if the students were ranked into a high math self-efficacy group, we see that the social belonging, it didn't really change much. But for the students in the low self-efficacy group, the student in the social belonging category, um, the gender gap was reduced there. So it was helping the students that we really wanted to help, the ones with this low self-efficacy about math and science. So what do you think? After all this, a student comes to you and says, maybe in office hours or at the beginning of the semester, I'm worried that I'm not smart enough to be here. What do you tell them? What do you do? What do you encourage them to do?
Well,
Sure.
Well,
Go.
go ahead, Kathy. Yeah.
I would like to put one of my colleagues on the spot. And Bob, you can decline to be on the spot, but wasn't there a female student a few years ago who in her first year was feeling like she was about to give up? And didn't you tell her something that helped her overcome that barrier, and didn't she go on to really flourish?
Oh, Kathy, that I almost am a little overwhelmed about that particular situation, but it has happened through the years that I have had many students come in who've had feelings of inadequacy, feelings of fragility, the famous imposter syndrome and all that. And the thing that I did was essentially, in my opinion, now after listening to this great talk by Emily, that I was playing, the role that you were playing with a group. I was telling them about my own inadequacies. I was telling them about my own problems. I was telling them about everything that happened to me. I was telling them that, boy, are they not alone. and it made a tremendous difference. I can say, I think it's fair for me to say, it has made a tremendous difference over the years to tell people these things, especially, here I am, this senior faculty person, and they come to me and when they say, oh my gosh, if he feels that way, it has made a difference.
So I have a confession to make, and I hope it doesn't make my faculty colleagues think less of me, but I had a very talented graduate student who ended up doing wonderful work. I mean, really, really, his work is just, I mean, the citations of his work are just increasing and increasing. And he flunked his qualifier the first time, which was in May. And I was to take him on as a research assistant that summer. And so I went to him and I said, he did particularly well on, particularly poorly on one part of the qualifier. And I said to him, okay, this is the way I studied, this is not a big deal. Spend half your time this summer studying for the qualifier, half your time working in the lab. That's what I expect of you. Here is the resource that I studied for this particular part of my qualifier. And I said, and I flunked my qualifier the first time, and it was no big deal. And his eyes got really big. And he said, you flunked your qualifier? And I said, yeah, no big deal. I passed it the second time. Nobody cares.
Mm-hmm.
But I think, I think that confession was maybe helpful to him. So.
Yeah.
So all my colleagues, yes, I flunked my qualifier the first time I took it. Now you know.
I think that students don't see that side. They don't see that you've had the struggle. Other, the senior faculty, they don't know your experience. They just think everything was easy for you. And of course it wasn't, but telling your story can make them, I think that's a great idea to help them feel like, this is really actually a normal thing. And it's really not that big of a deal, like you said. Yeah. few things that I'd like to add to, again, like was mentioned, you can grow your intelligence in physics if you're putting in the right kinds of study. Like you gave him good study tips and how to study for the exam. And learning from the mistakes, go back and look at the exam that you flunked. A lot of people paint it. They don't want to look at their exam that they got an F on. They put it in the backpack and they put it away. But really, they should think about going back and fixing the problems that they had issues with. And it's about personal growth, right? You can't compare yourself to other people all the time. You've got to remember that everybody's coming in with different levels of prior preparation. Some students had AP physics, some students had only conceptual physics, who knows? But it's about your own personal growth. And struggling doesn't mean you're not cut out for it. It means you're learning. If you're not struggling, you already know the material. So why are you even in the class? And of course, don't forget to study in a study group and ask help from your TAs and instructors as soon as you start to have issues, because you're a wonderful resource for them to understand better study strategies and skills. So and if you're thinking about implementing any of these kinds of interventions, here's just some practical tips. The main thing I would say is keep it brief. Doesn't take much. If you keep repeating it over and over and over again, students are going to think, this is getting to be too much, and they might not really respond to the message anymore. Keep it brief, but allow the student to kind of personalize it by having some kind of writing activity or reading activity. And make sure that if you do give some narratives, that they have a beginning, a middle, and an end. So if you give your own story, you have a beginning. Your beginning was that you were struggling, things got better, and this is where you ended up as a professor here. So and this is not a cheerleading session. Of course there's going to be difficulties and barriers, and some of those are actually barriers that are unchangeable, but they're not determining somebody's fate. Okay, that if you put in the right kind of effort and putting in the right kind of study strategies and skills, that that you can make it through. And remember that these kinds of acknowledgments to students, recognizing their concerns, and also recognizing their identity as a physics person. Students often don't identify with being a physics person, especially women, because they haven't been recognized by one as other people in their lives. So like their instructor may not think of them as a physics person, or their peers may not think of them as a physics person. And that's important in developing a physics identity. So, helping them, when they do research, when they write papers, helping them think about their identity as a physicist, can also help in terms of their sense of belonging and their self-efficacy too. So just some tips if you do think about doing something formal like this. Of course, there's just these general tips, but I think you already know this. Remembering to praise them for their hard work and effort. Students that are praised only for their ability or intelligence, as soon as they come up against something, and they will eventually fail, a test or a quiz or something, they're going to attribute that to, well, I wasn't smart enough, what's the use? But if they attribute it to, well, I just must not have studied the best way for that exam, that they can change that, right? So hopefully we can go from something that looks like this to maybe something that looks a little bit more inclusive and welcoming for many kinds of students. I really thank you again for coming to my talk and sharing some of your experiences as well. And I want to also thank my collaborators as well. And hopefully maybe someday we can meet in person.
Great. Well, thank you. Thank you for that wonderful talk. And yeah, I'm afraid applause on
Thank you.
Zoom.
Thank you so
Underwhelming.
much.
Can't show our appreciation adequately, but maybe we have time for a few questions.
Yeah.
Yeah, I have a question.
Go ahead.
Yeah. So in the beginning of your talk, you talked about a couple of aspects. So one was, I remember a couple of years back, I read this, rather listened to a talk by Professor Dweck from Stanford. So that had to do with this mindset, right? And then there was another one about belonging, and I'm forgetting the third one. So were you able to determine any correlation between them, or, just to how, so you talk about how there's this bias in the contribution coming from males and females, there's this bias. And we saw that in the slides where you talked about this, these belongings and mindset as well. So I was just wondering if we could give some percentage of contribution to these three aspects.
To their final grade, like their final performance.
For the final outcome, yeah.
The biggest one that we would do like a linear regression and put in the control variables, and the biggest one that we normally found that was a predictor of their final course grade was the self-efficacy. But it's hard to kind of parse them apart because all of these motivational aspects are all very much intertwined with each other. So if you looked at the correlation between the student's self-efficacy and their mindset, they were usually all highly correlated. But the biggest predictor that we found, besides prior preparation in like high school GPA or AP exam or whatever, was self-efficacy for the final exam, and that held true whether it was male or female students. Yeah.
Thank you.
So I'm going to jump in with a question that came through the chat. It comes to us from Claire through Kurt, and she writes, what do you do when the message is external, such as you can't join our study group because we don't have the time to help you, as the only woman in the class?
That's a great question. You've got to find at least for me, I do feel like that happened, at least especially whenever I was in grad school. And it's extremely discouraging. For me, finding at least one other student that I could work with to work on homework was a huge help, even if it wasn't, the big giant study group that was over in the room working on everything. Even if I could just find one other student, and normally it was another female student because I felt more comfortable with them. It's But I don't know if anybody else has any ideas on this. If the messages are external, it's really difficult to kind of overcome that. But trying, even if, and another thing that helped me a lot was a support system outside of school. My parents were a big help, even though they weren't in physics at all. They were really supportive and encouraged me to hang in there, even if I was feeling like, I don't belong and I can't get into the study group, so that was my own experience, at least. But I don't know if anybody else has something more tangible about that.
Can I just I have a
Yeah.
I just graduated in December. Okay, so kind of that was why me and some friends had wanted to start this Women in Physics and Astronomy Club.
Mm-hmm.
And I think we also now we have the like I can't PURMS, I think, the other student club. And I think that I mean, first of all, like we can, like, as professors, you can all make sure that that message isn't coming from like the faculty, the grad students, that sort of thing. But it's hard to control what other undergraduates are saying to each other and whatnot. But But I think that hopefully those student groups can do some of that work, and having support from the department, from the faculty, to make those student groups happen, and also to like counteract that message, like,
Mhm.
with these sort of intervention things, it seems like at the very least, if students are hearing that from other classmates, they're also hearing this, like, you can get better at this from the professor and instructor.
Mhm.
So I think that kind of, it's like pretty impossible to control what students are telling each other, but you can counteract that with the messaging.
Yeah.
So yeah, thanks, Hannah. And I should say that maybe we'll just take one more question in the formal session, but Emily has kindly agreed to stick around and chat with us a bit longer informally. So I'll let Corbin ask the final question, and then we'll move to the informal discussion.
Oh, okay. Well, thank you. I really enjoyed the talk, and I found it very useful, especially as I'm one of the persons in this department who teaches that kind of course that you were involved in, the first year course for calculus-based science and engineering students. And I just wanted to reflect on, even though I was aware of these ideas of what you're calling self-efficacy and social belonging, a sense of belonging, which I think have been really helpful. This notion of the growth mindset, it was something that's quite, I feels quite powerful, especially the idea that students can get into their head that they are not good and they can't grow. I think that's great. My quick question is, one of the things that's challenging to address these things is what I will call faculty intimidation, right? So when someone comes, there's a whole bunch of students who won't come to office hours or won't seek help, not because of anything that we do or say, but because of who we are. I suspect that it was easier to get things going in recitations than it would, say, in a classroom where a faculty was running things. Do you have any ideas about that? I mean, one idea would be maybe just to recruit people, but what about that particular issue, I would call it?
Well, actually, I think if you do these, if you at least have these kind of conversations at the very beginning of the semester, you might set up that environment where the student does feel more comfortable coming to you, but it's kind of in your court maybe to talk about some of these issues. Growth mindset, you can grow your brain, showing them the neuroscience behind it, and at least showing that you're aware of some of the struggles that they are facing. And so at that point, that's that special intervening time where they start to say, hey, at least my instructor knows that these issues are existing, and they may feel more comfortable coming to your office hours. They have that buffer now. They may have that buffer now, so they may feel more comfortable coming to your office hours and kind of taking that risk to come see you and possibly expose some of the things they don't understand. And I in my own classes at CCAC, I do remind them throughout the semester several times too. I always go back to it after the exams, especially the first exam. If they didn't do as well, I say, hey, there's other opportunities to pull up your grade, learn from your mistakes, but remember, this is a learning opportunity. This isn't like this this is a failure, but it's a time to learn from your mistakes, and struggling is okay. So reminding them of this message throughout the entire semester is also helpful too, I think. And I do have a lot of students that seem to be more comfortable coming to office hours when they know that you're aware of those things.
Right, that's a great answer. So what you're saying is just by starting that thing, you basically reduce the problem.
I think so, because it was almost like parched earth, like the students were really talking about it and really appreciative of the fact that we, were thinking about these issues. So bring it up as early on as you can.
Okay, great. Well, on that note, I think we'll end the formal proceedings and move on to private discussion. Thank you, Emily. That was a wonderful talk.
Thank you so much, everyone.